All right, so we are going to multiply these complex numbers and convert them into polar and trig form. Now, again, you have a choice. You could either multiply these numbers out, get it into Cartesian form, and then convert to polar and trig. Or you can convert to polar, use what you know about how to multiply complex numbers in polar form, and then use that. So here's your question. Do you want to multiply, then convert, or do you want to convert, then multiply? That's really what you're asking. And so I'm going to show you both just because um, I think it's beneficial and you kind of see why they work together. So I'm going to multiply. I'm just going to use this here so I don't have to rewrite that. -1 plus I. And so I get negative root 2. I get negative root 2I. I get root 2I. And I get root 2I squared, which is negative root 2. Okay. Just remember I squared equals -1. So if you don't know that, now you know. Yay. So negative root 2 plus negative root 2 is negative 2 root 2. Root 2I minus root 2I, these guys go away. Boom, boom. Okay, they zeroed themselves out. So now this is in Cartesian. This is in Cartesian form. If you want, you can write plus 0I as a reminder to yourself, but you don't have to. So here is Cartesian form. And now you would convert this to polar form. So polar form looks like this. It's r comma theta. So the first thing you're going to have to do is graph this. Now, because either your A or B are missing, that already indicates to me that we're not using our triangles. We're actually on one of our axes. So this says to go left -2 root 2 and then stay there. So here's our point. It's at -2, square root of 2. And I'm not even going to put plus 0 either. Okay. So you're supposed to imagine like this circle, this like circle. It was such a good circle and then I messed up. Okay. So you're supposed to imagine this circle and then that's what your radius is. So what's your radius in this case? What is your radius in this case? What is your radius in this case? Yeah. Actually, remember that your radius is always positive. Yeah. So it's just 2 root 2. So if you put a negative there, don't think that you're completely wrong. You just forgot that one little fact. Just think about you as a seventh grader. If I showed you, hey, this is our radius, and I said it was -5, right? And you'd be like, you can't do that. So because you couldn't do it you couldn't have a negative radius back then, you still can't have a negative radius today. And then I say, okay, well, what's this angle here? What is that angle? What is that angle? What is that angle? Very good. It's pi. All right. So then I'm just going to convert this to trig form. So here's my answer. Sorry. This is my answer for polar form. And then to convert it to trig, you're just really plopping it in that the form of r cosine theta plus I sine theta. So I'm just going to plug my numbers in and then I'm done. So that becomes 2 root 2. And then I got cosine something plus I sine something, right? And then our angle is pi, so we just do that. So here's my answer, right? So that's the work that you would do if you multiplied first, then you converted. So, but what happens if you convert first? So when you're converting first, you have to convert each number. So here, in terms of polar, I'll have two r thetas. I mean, I'll have two sets of r theta. Okay. So I'm going to draw this out really quick. Root 2, let's see, root 2, that's this guy. You guys should already be recognizing that triangle there, root 2, root 2. You should be recognizing this triangle as your 45, 45, 90, which already indicates my theta, right? So this is r comma theta. That already told me what my theta was. It's pi over 4, right? So then this guy, this is going to be root 2 times root 2 because it's our 45, 45, 90 triangle. So it's just 2. So we got 2 comma pi over 4. And some of you are like, Miss Johnson, it's not looking so good. Because look at what your answer is in r theta. How are you going to get it from 2 to 2 root 2? And don't worry, it'll happen. So that's my first set of numbers. I'm going to do my second set right here. So the next one is -1 up 1. So this is my next one. Oh, look, it's also a 45, 45, 90 triangle, right? So this is root 2 here. So there's my radius. It's root 2. And some of you are already seeing, oh, that's how you got 2 root 2, Miss Johnson. Exactly. And then I have to figure out my angle, which is this guy here. And then we talked about this. If you have pi over 4 slices, this is my little drawing for it right here. If I have pi over 4 slices, imagine 4 slices of pi. Do you see it? Here's 1, 2, 3, 4. Okay. So then I took one of those slices away. Now you only have 3 pi over 4 slices. Okay. And then we go over here to our operations list. I made it earlier for you guys. So your operations list is when you're multiplying in polar form, you take your r's and you multiply them, and you take your thetas and you add them. So when we multiply these numbers here, when we multiply them, let's put it this color. I don't know, maybe this color. Sure. When we multiply these, so we are multiplying them, we're going to go 2 times root 2, and then we're going to add pi over 4 plus 3 pi over 4. Does that make sense? So we're adding them and multiplying them. So just kind of follow that little color coordinated chart there. So then I'm just going to simplify. So my answer is 2 root 2 comma pi over 4 plus 3 pi over 4 is pi. And so notice we got the same exact answer. Right? Which way do you like better? Great, do that way. And then plopping it into trig form, that's no different. It's going to be the exact same, so I'm not even going to do that. So yes. So when you're multiplying, which way do you prefer? Do you like multiplying and then converting, or do you like converting then multiply? Some people don't like converting first because look, you have to do 2 sets of triangles, so that makes sense to me. Some people like using that slick trick of multiplying your radii and adding your angles, so that's pretty good too. All right, thanks for listening.